All right, we're live. Right.
Okay. So lesson 6 first.
Yeah.
Okay. Have you guys gotten the emails from the TA?
Yes, I have.
I haven't checked. It was a couple days.
Do we need to do anything with that? Or do we just wait?
Well, she says we have to like set up an appointment with her.
Yeah.
She can come to our meeting.
Oh, that's right. I remember him saying that.
Okay. Yeah. Okay. 1 and 2.
Matthew, want to go play soccer? Matthew, do you want that? Who's supposed to be on
You
that?
want me to read them?
Sure.
No, 1 and 2. I love those ones. Okay, number 3. When using the when, taking samples of n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed?
Wouldn't it be skewed right?
I think that sounds good.
They said like as n gets bigger, then it becomes more normal.
Uh-huh.
Okay.
I would say skewed right, too.
Yeah.
Okay. Number 4. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is skewed right?
So that one I think would be normal.
Normal.
Got bigger. Okay, 5. When using the sampling distribution applet, when n equals 5, what was the shape of the distribution of means histogram when the parent population is normally distributed?
Would that be normal?
I think normal is right.
I think it would be normal. That's what I'm.
I want to say normal.
I would go with normal, too, because if it's normally distributed, the shape's not going to be some funky thing, you know?
Yeah. Okay. 6. When taking samples of when n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed?
I feel like that would be the same.
Me too, because doesn't it get more normal the bigger it is?
Yeah. When taking.
That's kind of sketching me out that they're all normal.
Yeah.
I guess we can get onto that thing he was using and try it out. I just can't remember where he went.
I think I got it. So n equals 100.
I feel like it still would be normal though. Because I'm looking at the prep assignment too, and it's saying how, so one of the questions was, what is the shape of the sampling distribution of the sample mean when the data are normally distributed? And that would be normal. And then the other one was, what is the shape of the sampling distribution of the sample mean when the data are not normally distributed, but the sample size is large, and it still would be approximately normal. So the fact that it's normally distributed, I feel like that's where it, and on top of that, we're working with n equals 100.
Right.
Yeah. I feel like it's normal. Are we still
So
sure
that's like
about number 5?
Double one. Now 5, that's the thing. It's a low number, but the parent population is still normally distributed.
Does anyone know where he went to use that little?
The applet,
Yeah. Do you know what it's called?
I don't.
I can't even remember what he called it. Maybe the central limit something or.
The central limit theorem.
Yeah, I just don't know where he. Dang it. Maybe he used that in. No, he didn't. Oh, maybe it's this. Okay, I got to it. Now what do I need to do? So I got to that applet thing he was using, and I just have the parent population is normal, and then I clicked the 5 for n equals 5 and did it 5 times. And it doesn't, I mean, I don't know how many times I'm supposed to do it. If that makes any sense. I don't know.
Oh, yeah.
Do you know what I'm talking about? Like when he was doing it on the applet, he like kept pushing it like 10,000 times or 5 times or whatever.
Like in those videos, is that what you're talking about?
Yeah.
Okay. Yeah, he pushed it a lot of times, right?
Yeah, like he would do it like 10,000 times for like a good number to see what it would look like. So I did 10,000 times when n equals 5 and it's normal.
It's normal.
Yeah, if I do it 10,000 times.
Well, then I think that.
So then I say we just go with it.
I mean,
Yeah.
if that's the question's asking, I hope it's not.
Yeah, that makes sense. Okay.
So for 4, 5, and 6, then we have normal, and for 3 we have skewed right,
Yes.
because that was right skewed right.
Well, what do you think about 4 because it doesn't say normally distributed? Are we
But
still
the sample was kind of big.
okay?
I don't know.
start,
What do you guys think?
I start to overthink it when I go back
No.
and look at it too many times.
Same here. I am the same way with math. Like, if I really, like, stay on one question a lot, I start questioning it all.
Yeah. So I think we
Well,
can.
here's the thing, because it says n equals 100, but you can't put 100 on this little applet. It only goes up to 25.
Yeah.
So,
Okay.
but if you do 25 and you do it 10,000 times, you get a normal distribution, even if the parent population is skewed.
Okay.
So I don't know. I don't know if, like, if you just do it 10,000 times, just be safe and see what it does, or what.
I'm not sure.
I don't know. I think maybe we should keep our answers and just see.
I think so too.
Okay.
Let's go to 7. Okay. When would the distribution of means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from a population that is right skewed and the sample size is small. Data are drawn from a population that is right skewed and the sample size is large.
What I would choose is 2 and 4.
Okay, that's what I was thinking.
I think it's
We
all
have-
of them but the third one. So I think it's 1, 2, and 4.
Because the first one says normally.
Yeah, because if you use the
Oh.
applet, you have a normal parent distribution, then
You're right. That's like just the one we were working with. We had 5, but it was still normally distributed.
yeah.
Okay.
That makes sense.
one.
So 1, 2, and 4.
Yeah, that's what I would think.
So I pulled up the lesson thing online, and it says that if the parent population is normal, then the sampling distribution will always be normally distributed, no matter how many observations are selected.
Oh, okay.
So
that would mean like 10,000 or 5 or whatever.
yeah, that's what it goes on. If the population is heavily skewed, then it will require a larger sample size.
Yeah. And that makes sense.
Okay.
So
So we're good.
Yeah, I think so.
Okay. Which of the
1, 2, and 4.
Yeah.
Yeah.
Okay, so number 8. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, the sample mean will follow normal distribution. For bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean. About 95% of the data will be within 2 standard deviations of the mean, and approximately 99.7% of the data will be within 3 standard deviations of the mean. If the sample size is large, the sample mean will be close to the population mean. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. Well, the second one is true, right? Because when you do the bell shape.
Yeah, but that's the 68, 95, 99.7 rule. I don't know if that's considered the central limit theorem. Because the central limit theorem says if x is a random variable that has any distribution with mean and standard deviation, then the sample mean based on a sample size of n will have a distribution that approaches a normal distribution as n gets sufficiently large. So the larger the sample size, the closer to a normal distribution is what it's saying.
Also, that last one though too. The sample
That's what
size
I'm
is
thinking.
large. The shape of the sampling distribution of the sampling X will be approximately normal because we know that. No matter if it's skewed left or right, if it's large, it's going to end up being approximately normal.
That's what I'm thinking, but isn't the first one also right?
I feel like there's a little bit of truth to each of them.
Yeah, I don't. I think I want to go with 4, but that's one that like you could.
That's, yeah, no, you definitely could justify number one, like the answer, the first answer too, the first option.
Yeah.
You definitely could.
But I think if we're just going with what the central limit theorem says, I think 4
Could
is
be
our
that
best.
last one.
Yeah. Really? Stop.
Okay, so we're good.
Yeah, I think so.
That's the last one.
Yeah.
Yeah.
Okay, 9. Let X be a random variable with a population mean 10 and population standard deviation 6. Suppose the sample size n equals 36 is drawn from this population. What is the mean of the distribution of the sample means?
That would be 10. I think. Wouldn't it be 10?
So, well, this one you'd have to do the. Hmm. Well, the mean is 10, but it's asking what is the mean of the sample means. Is that? I feel like 10 would just be too easy.
No, the mean of the sample is the U.
Yeah, it's
Simple.
the same. The same, I think.
Because if you look in the lesson page or whatever, it says the mean of the sample mean is the U thing.
Hmm.
I agree.
I think you're right.
The standard deviation is the one where you have to do an equation.
Yeah.
And the z-score, right?
Yes. Takes me a while to process it through my head.
Okay.
Sorry,
Alright,
I'm like
I see what
so
you're saying.
slow.
Okay, so we're just going with 10 then.
Yeah.
Okay.
Okay. Number 10. What is the standard deviation of the distribution of sample means? 3 decimal places.
So this is one where you have to divide it by the square root of n, right?
Yeah. So you do the standard deviation divided by the square root of n.
So it should just be 1, right?
Wait, what did you say that you do?
The standard deviation divided by the square root of n. So it's 6 divided by the square root of 36.
Which is 6. So 6 divided by 6 is 1, right?
Things right.
So.
So just do like 1.000 or something?
I guess.
This says 3 decimal places, so
You did 1.000.
yeah, I think so. If it's just if it still wants 3 decimal places.
Okay. So we're all good?
Yeah.
I think so.
Yeah.
11. Regardless of the distribution of the population, if the sample size is large, what would be the shape of the distribution of the sample mean?
That would be normal.
Yeah.
Right?
Yeah, I think so. Yep.
So.
Okay, what theorem would justify your response to 11? Law of
That
large
would be central limit.
or central?
I think it's the law of large numbers.
The law of large numbers states that as the sample size n gets larger, the sample mean x will get closer to the population.
But yeah, look back at number 8 and the one where we were working. Which of the following gives the best explanation of the central limit? Right there, we're saying if the sample size is large, then it'll be normal, and that's kind of the same thing
I
as
think
what
it's
11
the
is
central
saying.
limit theorem.
I think so too.
I think it is.
So that we're doing the central limit theorem.
That's what I say.
I think so. Okay, so we're all done, right? That was it?
Yeah.
Yep.
Yay!
Perfect.
Sweet.
I like that. We have a test next week, right?
Yeah, on
Yeah.
Wednesday, I think.
Did you guys see that you put a deadline on that group meeting for Tuesday?
Yeah, I saw that today, and I was wondering if that was just for this week's, it has to be turned in by then, or if that was for next week's.
I don't know. I was gonna ask him at the class meeting and I missed it. So I
Okay, wait, what are you talking about? What did I miss?
It said on
Let's-
Tuesday, this coming up Tuesday, that the group meeting is due. But I wasn't sure if it's this week's group meeting that it has to be turned in by then, or if it's
Or is
next
it
week.
next week so that we're done before we have the test?
That's what I was thinking. That's the only thing I
Could
could think
be.
of because then the test opens like on Thursday or something.
I think it's next week's group meeting.
Yeah, that would be probably to make it so that it's done before the test.
The test.
I think
Yeah.
so.
Okay, so we'll
So
plan on.
should we do also meet Tuesday then?
What did you say? It cut out, sorry.
We'll plan on meeting Tuesday then?
Yeah, like at our normal
Yeah.
time?
Okay,
Yeah, I can do that.
Yep.
that works.
Okay. What is our normal time for Utah?
2:30? Oh, for you guys
3:30?
it's 3:30.
Okay, so that's 2:30 my time.
Yeah. I'm so glad we didn't do 2:30 today because I got off of work and my car was dead, so I had to call AAA and it was a mess. So I'm so glad that it worked out that we had it later today.
That's so frustrating.
Yeah.
I hate car problems.
I know.
Okay, lesson 7.
Yep.
Yay. Yay. Okay. Number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round to 3 decimals.
Okay.
What's the easiest way to get to the normal probability applet? Is it?
Just go to the online textbook, and you can
And
go to
it'll be there.
resources, and it's right there.
Hey, Mom. I found my table just now. Hey, Mom, you're gonna have to turn on the computer because for one this one I'm gonna. Oh, really? Okay. Okay, I need a pencil too.
Okay, I got 0.8255. I guess it'd be 0.826 if you round it.
0.826?
Yeah.
Round it. Okay.
Anyone else getting that?
0.826, right? Is what you guys got? I got that.
I think so. Well, let's see. No, wait, let's see. Hold on. The right and to the left. So maybe. Actually, no, that would be 0.175. Right? Because it's just, if you just put in the z-score, it just wants what's the blue on either side.
Oh.
So I thought it said like in between, but it's saying it doesn't say in between them. It just says to the right and to the left.
I think it would be 0.175.
I think so too.
Okay. Number 4. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in the sample. Round to 3 decimal places. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
So is this kind of like we have to find the z-scores for these?
I'm actually really confused by this.
Yeah.
It's kind of a lot.
It almost sounds like the same kind of question as number 3. We just need to find the z-score itself.
Ooh. So find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than observed in the sample. I actually have no idea how to start doing this. You guys understand it?
No, not really.
I do think we have to do something with the z-score, but I'm not exactly sure what.
Okay, so I think we use the z-score formula, which is the sample mean minus the mean. Oh, no, wait. Yeah, the sample mean minus the mean over standard deviation divided by square root of n. Do you guys have that formula written down?
Yeah.
I think that might be the one that we use because we have everything that we need for that. So you would do the
Right? More than enough.
So would you do 185 minus 177.6 and then divide that by 26.7 divided by square root of 48?
This is working with the what's it called? Well, we're trying to find the probability that random sample pastures will have a weight that is as extreme or more extreme. So I think it's working with that applet and seeing, or that one rule, and we're getting how much will weigh as much as 177.6 or more. If that makes any sense, it probably doesn't.
Okay. Well, do I have to find the z-score though? Are you talking about the probability applet?
Yeah.
So we need the z-score for that.
So I got 1.920 for z-score by using that formula.
Mhm.
Did anybody else get that?
I did.
Okay. So when you put that in the applet, then is it asking, let's see, asking for extreme or more extreme? So would that be just to the right and to the left?
I think so.
So it'd be 0.0549?
The thing is, though, is that we're working from the mean. So the mean would be the middle of it, and then we're doing that and everything above it.
Well, it says either above or below the mean. So
Yeah, because it's asking for whether it's extreme or. Oh.
But then it does say no, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away.
When it says that passengers will have a weight that is as extreme or more extreme, either above or below the mean. So does that include the middle, or is it
Yeah,
just?
that does include the middle.
well, then you just get one because when you have the whole thing.
Although, if we include the middle, that would be within like the range of normal.
Mm-hmm.
Yeah, that's what I'm thinking because uh, it says either above or below the mean. So I'm thinking that means to the right of the z-score and to the left of the z-score, which would just be the parts in blue that it highlights for you.
I think so too.
So if you
I think
round
we
it,
try that
it's
then.
0.055.
Did you say 0.55?
Just
0.055.
0.55.
Okay,
That
it keeps.
could be completely off, but I don't really know.
I think
Okay,
that's our best bet.
it keeps
Okay.
coming out. What did you say it was?
0.055.
But it has to be to 3 decimal places.
Yeah,
That is-
0.055. 0.055.
Oh, duh. Today's not my day. Everything in my house keeps breaking. Okay. I was 0 help on that. Like, I'm still. Okay, 5. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, x. The distribution of the sample mean cannot be determined.
Wow. Show me if you can go in the kitchen. What? Got an email? Huh? Mom, I will. No? Yes. No? Mom, I will.
I'm not really sure what.
Yes,
I don't really
you
understand,
will.
like.
No, it's not. It won't. I will still do it. Yes, I will.
Because I'm not understanding it, I'm saying it cannot be determined. But I don't know if that's right. That's just because I'm not understanding the question.
Like, after I read the question, the answers don't make sense. 'Cause
Yeah.
Let me go. Can I buy it? Why not? Mom, I will if you can buy it.
Matthew, shut up.
Mom,
Look, they're all laughing at you because they can hear you.
I'll still do it. Mom,
Oh my gosh. I'm sorry, guys.
please.
I-
Mom,
no idea.
You can still hear it. Come over here.
Mom. Mom.
Okay. Yeah, I'm really not getting this one.
Okay, so what will have a smaller standard deviation, the mean or the sample mean of the mean?
I'll still do that. I'll still do it before I even get to play. Mom. Mom.
Part of me thinks it's individual, but I'm probably
Then after we got it.
I feel like it can't be determined because you don't know if the individual ones are going to be less than the mean.
That makes sense.
I'm stuck.
Yeah, because I don't know if you'd be able. Well, you can't find out the standard deviation unless you have the mean. Is that what you're saying?
Yeah.
Okay, so maybe we should just do cannot be determined.
That's good.
Okay.
Okay, number 6. Which of the following results implies that the spread of, what is the x with a line over it?
The mean of the mean.
Okay, decreases as the sample size increases.
So that one would be the law of large numbers, right?
That's what I was thinking.
If it's talking about the spread, then the spread would be the standard deviation. Right?
I think it's the law of large numbers.
Yeah, because if the standard deviation decreases, then n increases, is what I have in my notes. So I think it's the law of large numbers.
I think so.
Yeah.
Okay.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed, with mean 150.8, standard deviation 8.8. Use this information to answer questions 7 through 10. Oh, geez. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? 3 decimal places.
I got 1.045.
Are we all good with that?
Did anyone else get an answer?
I'm still looking. Figuring it out.
Has anyone else got an answer yet?
Do we put that in the applet?
No, this one's just asking for the z-score, so you just use the z-score formula.
Oh, okay.
But at number 8, I think you use the z-score and put it in the applet.
So you put the 1.045.
Yeah, in the applet, because it's asking
That's what I got for the Z score.
1.045.
1.045. Mm-hmm.
Okay, cool. So for number 8, I think you just put that in
That's
the
what we
applet,
put.
and then find the area to the right at the z-score. So 0.148 is what I got.
0.148 is what I got too.
Okay.
Me too.
Awesome.
Okay. 9. A random sample of 5 students was selected to take the GRE. The scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' score?
Is that the same as number 7?
It is, right?
Because did you get 160 for the mean?
Oh yeah.
Yeah.
So it should be the same, right?
Yes.
Okay. Weird.
Yeah. Like I kept
I think
looking.
they're trying to confuse us here.
Okay, 10. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Isn't that the exact same as number 8?
It is, right?
It is,
The
because it's
mean in
asking.
number 9 was 160, so it's the same question as number 8.
Yeah.
Ah, that's weird.
But now 4 decimal places, so it'd be 1480, right? Pretty sure that's what it was.
Yeah.
Yeah, 1480.
Yep.
11. Okay. Suppose the mean GPA of BYUI students is 3.5, standard deviation of 0.7. It is well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. Use this information for 11 through 15. What is the shape of the sampling distribution of the random variable, which means the sample mean of the 81 students who are selected?
Since it's over 30, it should be approximately normal.
Yeah, that's what I would go with.
Me too.
Okay. What is the mean of the distribution of the sampling distribution for all possible samples of size 81 that can be drawn from the parent population? Round to 1 decimal.
Is it 3.5?
3.5 is what I would say.
Yeah, that's what I would think.
What is the standard deviation of the sampling distribution of the random variable? The mean of the 81 students who are selected. Round to 3 decimals in this one.
Okay, so this one you would do the formula, right? You get 0.078.
.078, right?
Yeah, that's what I got.
I got that.
Okay, cool.
14. What is the probability that the mean GPA for 81 randomly selected BYUI students will be less than 3.3?
You got 0.387.
Did you say 0.387?
Yeah.
That's what I got.
Okay. Awesome.
That's what I got.
What is the probability that the mean GPA for 81 randomly selected BYUI students will be greater than 3.3?
So that'd just be 0.613, right?
I think so.
You just subtract that from 1.
From 1.
Yeah.
Wait. So are we good then? Are we done with those?
I think we're all good.
Yeah.
Okay. Cool.
Ooh.
You guys get a C?
Yeah.
Yeah.
Why?
The distribution.
What in the world? Oh. God. What? Oh, dang it.
Nine and 10 really like throw me off.
Yeah.
Yeah, we just used the wrong formula.
They're wrong.
Dang it, we should have known that because they were the same answers. Dang it.
Hmm.
Yeah, because it says sample mean.
At least we didn't get C's on both of them.
Yeah.
Yeah.
Way to look at the bright side.
Got an A on like all the other ones, so.
Yeah.
So, did we do the wrong thing on... How did we get number 14 and 15 wrong then? Didn't we do that for number 14? We did that same formula?
I thought we did.
Not quite sure why we got that one wrong. I guess I'll have to ask him about those because I don't understand that.
I guess the formula we did was wrong.
But that's what I did. I did the 3.3 minus 3.5 divided by 0.7 divided by the square root of 81. I must have just...
Well, and it's supposed, if you put it into the
Maybe I
applet,
didn't.
it said the left side, and so the left side is 0.0051.
If you put in 2.57,
Yeah.
because I did that and oh, I know what I did. Okay. Dang it. Alright, well, hopefully we'll do better on our individual homework assignments.
Sounds good. All right, so then we're just gonna plan for Tuesday then at normal time to do that review. It's just a review, so I just looked at it. The prep assignment is what the quiz is gonna be. So as long as we all do that, it should be pretty simple. Just input our answers for the quiz.
Perfect. Okay, so Tuesday at 3:30.
Yep.
Okay. See you
Sounds
all
good. We'll see you
All right.
guys.
Yeah.
then. Bye.